In this project, we're going to create a photo gallery app called PhotoGRID. PhotoGRID lets the user upload photographs using a very simple to use interface. Every photo that displays up in the gallery also has a vote up feature that lets you rank images based on your preference. All photos that are uploaded using PhotoGRID are stored in an Amazon S3 bucket, which is essentially a storage service provided by Amazon in the cloud. Our app also runs on an Amazon Elastic Compute Cloud instance. This is how the app looks like. As you can see, we have an input field that lets you select the files that you wish to upload, and we have an upload button that initiates the upload process. Once the files get uploaded, they are displayed in the gallery interface as you can see on this page. Every image also has a vote up button that the user can click to increment the vote count for that image. This is how our app works. The Node.js app runs on an Amazon Elastic Compute Cloud instance. When you upload an image, the image is first resized using the Graphics Magic image processing library, and it is then pushed into an Amazon S3 bucket from where it is displayed in the gallery interface that you saw in the previous slides. Additionally, an entry for the image is also made in a MongoLab MongoDB database. This is where we keep a track of the vote count for every image. So what are the learning objectives for this particular project? Well, the first and the foremost being the use of Amazon Web Services. Amazon is the world's foremost provider of cloud computing infrastructure and related services. Using Amazon's amazing set of services, you can power up your tech startup in no time without worrying about upfront costs. As your business scales up, you can scale up the computing capabilities of your cloud infrastructure and consequently benefit from such scaling in terms of operational expenditures and computing capabilities. Therefore, it becomes very important for developers to understand and be able to deploy their apps on the Amazon cloud. In this project, we would be mainly using two of the most important services that Amazon offers. The app itself would be set up on an Elastic Compute Cloud or an EC2 instance. Think of an EC2 instance like a virtual server running in the Amazon cloud. You get full control over the server's computing capabilities, its operating system, storage, and bandwidth. Therefore, you can start at the lowest configuration and scale it up seamlessly as your business grows. To store our image files, we will use the Simple Storage Service or the S3. An S3 bucket is essentially like a folder that is optimized for storing and delivering assets such as images, video, and virtually any kind of file. This way, we do not tax the storage that comes attached to our EC2 instance, and we leverage the capabilities of the S3 bucket instead. So let's take stock from the beginning. We'll first see how file uploads are handled in an Express app. We will then set up and use the Graphics Magic image processing library, which will allow us to resize the photographs down to an acceptable size before we push them into the S3 bucket. Like earlier, we will be using the services of mongolab.com in this project as well, along with the Mongoose module. We will then create an EC2 instance and we will configure the instance first to run a Node app. Then we will upload and set up the PhotoGRID app on the instance and prepare it for production use. We will also create and configure an S3 bucket for use with our app. Additionally, we will also use Amazon's CloudFront service. This service lets you set up a content delivery network or a CDN based on your S3 bucket. This way, Amazon pushes the files in your S3 bucket, which in this case would be images, to its network of data centers across the world so that it gets delivered optimally from a data center near you. I must also point out that I have intentionally left out functionality to make this project simple to understand. The focus is on practically absorbing the concept behind the project. For instance, there is no authentication feature in this app. However, you can extend the capabilities and add Facebook authentication yourself based on the methods shown in the ChatCat project earlier. Similarly, the vote up feature simply increments the vote count by 1 whenever the user hits the button. By keeping the concept simple, my aim is to lead you in and allow you to carve your own path as you write this app and possibly extend its capabilities to include features such as authentication and perhaps image processing capabilities. So let's get started. Begin by downloading the user interface files.